Good morning students. Today we will see about phases of compiler in the course compiler design. So the phases of compiler has this structure. So this starts with lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer and code generator. Okay, and this side we have symbol table and this side we have error log. So totally 6 phases we have. This is also called as structure of a compiler. So the first 3 sections are called as front end of a compiler, and this 3 are called as back end of the compiler, and this phase is also called as analysis phase, and this phase is also called as synthesis phase. So this phase is also called as front end or analysis phase, and this phase is called as back end or synthesis phase. Okay, so now we'll see what each of these phases are going to perform, and with respect to this example. Okay, so this analysis phase generally takes your program and it divides the program into tokens and impose the grammatical structure on the programming language. Okay, so let us assume this is your input A is equal to B plus C. What your lexical analyzer will do is it scans from the left to right and divides, it removes the white spaces in between and makes the token. Okay, generally these spaces are called as lexeme, and it sends it for the evaluation. The valid tokens are called as lexeme. Okay, so now this token, like, it will take it as ID and gives the name as 1. Okay, and this B will be taken as ID and this token is 2, because in the symbol table we'll have the structure like this. Okay, so ID and this entry is 1 and this entry is 2, and we'll have ID C as ID 3. Okay, so ID 3, this is how it is named. And if suppose we have termed it as float, the value of this will be placed, and let it be int and let it be float. Okay, so this is how it is stored in the symbol table, and this is your symbol table structure. Fine. And now this lexical analyzer will be scanning from the left to right, and it will divide this into tokens and make an entry in the symbol table. Okay, and now at the end you will have the structure after this phase 1. It is like ID comma 1 and equal to, because this equal to it is going to be identifier and value pair. Okay, and now for this it is only an assignment variable, so there is no value for this, so it is kept as such. And ID comma 2 plus ID comma 3 star and 50. This is how the entry in the this is how your tokens formed after this lexical analysis phase. Okay, and the second phase is called syntax analysis phase. So what the syntax analysis phase will do is it will check whether all the syntax are correct against your language structure, and it also makes the abstract syntax tree. Okay, so like, this is your abstract syntax tree. For the convenience, hereafter I will call it as ID1, ID2 and ID3. Okay, so your abstract syntax tree is like this. Okay, ID1 equal to plus ID2, ID3 star ID3 into 50. This is what your abstract syntax tree is. It serves in 2 purposes. One is this abstract syntax tree will check whether all the syntax are correct, and moreover it also checks whether in what way your expression is going to be evaluated. Okay, So after this lexical analysis, this output is to be output is given as the input to this lexical analysis phase, syntax analysis phase, and this abstract tree will be the input for the next phase, which is called as semantic analysis phase. So together this syntax analysis phase and the semantic analysis phase will serve as the parsing. Okay. So during this semantic analysis phase, we are going to draw the parse tree, which is going to be the input for the intermediate code generator. Fine. So here your abstract parse tree will be id1 equal to plus id2 star id3, and here int to real of 50. Okay. So what exactly this semantic analysis phase will do is, it will check the type checking. The major purpose is here is to type checking, where for example here I have made it as 50 and this id3 I declared as float. Okay. Previous to this in my programming structure, I would have declared this as float. If it is int, I can keep as such, but I assumed that I have declared it as a float. So for this purpose, I can't keep it as such. I will have to type convert this into a real number, into a float number. Only then I can do the multiplication with this id3. Okay. So I am converting it into an int to float, and I am multiplying that with this id3. And now this is way, in this way the computation will happen, like id this and this will get multiplied, and the intermediate result will get summed up with id2, and that will be assigned to id3. Okay. Now we will go with the intermediate. This is the work of the semantic analysis. So the semantic analyzer majorly checks for the, majorly do the type checking work. Okay. And this parse tree will be given to the intermediate code generator. So this intermediate code generator generally will be 3 address code. We have multiple intermediate code representations. We will see those things in due course. But today what we are going to see is the intermediate code, 3 address code. Okay. 3 address code I'll just write. Okay. So 3 address code will be like T1 equal to T2 plus T3. So one operand, left side one operand and operator and the other operand. So this is how the 3 address code is all about. Okay. So now for this example, the 3 address code will be so T1 is equal to int to float of 50, okay, 50.0, and T2 is equal to this id 3 star T1, and T3 is equal to id2 plus T2, and id1 equal to T3. Okay. So now this is the intermediate representation of the code which is given here. Now we will do the fifth phase. We will see the fifth phase, which is going to be the code optimizer. So this code optimizer is the major part of the compiler. What it does is, it will remove the the error code, dead code, and there might be some part of your code which cannot be reached through any of your conditions, right? So such codes will be removed from your program. Okay. So let us see, we'll also see one optimization here. For this, let me do T2 is equal to id3 star int to float of 50.0. Okay. So this temporary variable we have removed, and T3 is equal to id3 star T1, and sorry, plus T1. So this is only we have this T3 only we have again assigned to ID1. So instead of using this, let me straight away assign to ID1. Okay. So now T2 is equal to ID3 star into float of 50 and ID1 equal to ID3 plus T1. Okay, so see here we have 4 lines of code which you have reduced into 2 lines of code. Okay, and next we will see about the code generation. Code generation phase. Okay, so in this code generation phase, generally the compilers will generate the target code. It varies to the programming language to programming language. In C program, the target code is going to be C and C++ code. The target code is going to be an object code. In Java, the target code is going to be the byte code. So in general, the compilers create the target code, which is assembly code. Okay, which is assembly code. That is what we are going to learn throughout this course. So this assembly code, what is our code is ID1 is equal to ID2 plus ID3 star 50.0, right? So for this we are going to write the code. Now we are going to load LDR. We'll load this. So LDR R1 comma ID3. So this ID3 will be getting loaded into R1. Now I need to multiply. So MUL R1 comma R1 comma star of 50.0. So I'll it is the immediate variable, a constant variable. It is I am loading it directly. That will get multiplied with the content of R1 and that will get stored in R1. Okay, and next I need to load R2. So LDR R2 comma ID 2. So this ID2 variable is getting loaded in R2. Now I need to add. So add R1 comma R2. So I'm adding this ID2 variable along with this R1, which is the intermediate result of this. So that is getting added and the result is getting stored in R1. Now the entire result is in R1. This computation result is in R1. Now I need to store it in ID2. So store register ID1 comma R1. So R1, the value which the entire computation value is available in R1, that is getting stored in ID1. So our computation is completed. Okay, so today we have seen phases of compiler. So we have 6 phases in the compiler. First 3 phases is called as analysis phase. Second 3 phases are called as synthesis phase. So the compiler in the first 3 phase, it analyzes your code and it will at the end of this analysis phase, it generates the intermediate code. And in the second phase, which is on the synthesis phase, which is on the back end of the compiler, it will produce the code, which it will produce the target code. Okay, thank you. Happy learning. We'll meet you soon.